There are rules that we have to follow in multiplying radicals. To multiply radicals of the same order, use the property nth root of a times b equals nth root of a times nth root of b. Then simplify by removing perfect nth powers from the radicand. For example, square root of 3r squared s cubed t raised to 5 times the square root of 12r cubed s squared t. So the first thing that we have to do is to multiply the whole radicand of the first term by the whole radicand of the second term. Doing so, this expression would be equal to 3 times 12, that is 36. R squared times r cubed is equal to r raised to 5. S cubed times x squared is equal to s raised to 5. T raised to 5 times t is equal to t raised to 6. And then now we can apply the law of radical nth root of a times b equals nth root of a times nth root of b to this expression to simplify this. So the square root of 36 times the square root of r squared times the square root of r, because r squared is equal to r raised to 4 times r, and that is r raised to 5, times the square root of s squared, because this s squared is equal to s raised to 4 times another s, which will make it 5. And then for the variable t, that would be equal to the square root of t cubed squared, because t cubed squared is equal to t raised to 6. And then let us simplify. Square root of 36 is equal to 6 times the square root of r squared. We can cancel this. We can cancel this out. So the remaining will be the radicand r squared, and then the square root of r. And then we can also cancel this out. So s squared will remain, multiplied by the square root of s, times, cancel this out, times t cubed. Arranging the terms, this would be 6r squared s squared t cubed square root of r square root of s. And this would be our final answer. To multiply binomials involving radicals, use the property for the product of two binomials a plus minus b times c plus minus d equals ac times ad plus minus bc plus minus bd. Then simplify by removing perfect nth powers from the radicand or combining similar radicals. Example: square root of 2 plus square root of 7 multiplied by the difference of square root of 8 and square root of 6. So to solve this, we may use another method which is the FOIL method. So we only have to follow these steps. The first terms that we have to multiply are the first terms, and then the outer terms, and then the inner terms, and the last terms. So now let us identify the first terms. The first terms are square root of 2 and square root of 8, and we have to multiply these terms. The square root of 2 times square root of 8 is equal to square root of 16. Next are the outer terms. For the letter O, the outer terms are again square root of 2 and negative square root of 6. So that would be negative square root of 12. The third one is the inner term, and the inner terms are square root of 7 and square root of 8. Multiplying the two, that would give us a product of positive square root of 56. And lastly, the last terms, which are square root of 7 and negative square root of 6. That will give us a product negative square root of 42. And then we can simplify this further. The square root of 16 is equal to the square root of 4 squared, because 4 squared, or 4 times 4, is equal to 16. Minus square root of 12, that could be written as the square root of 4 times the square root of 3, because 4 times 3 is equal to 12. Plus the square root of 56 may be written as the square root of 4 times 14, because 4 times 14 is equal to 56. And then square root of 2 would remain, because we cannot factor it to two different numbers having a perfect root. So that would stay as it is. Okay, so for square root of 4 squared, we may cancel this out, so 4 would remain. And then again, the square root of 4, we already know that that is equal to 2 times the square root of 3. Plus, again, the square root of 4, that is 2. And since 14 is not a perfect root, it would remain under the radical sign. And then minus 42. And this would be our final answer. To multiply radicals of different orders, express them as radicals of the same order, then simplify. Example: the fourth root of 4 times the cube root of 2. So to do that, the first thing that we have to do is to make the radicands have the same base. So we can rewrite the fourth root of 4 as the fourth root of 2 squared, because 2 squared is equal to 4 times cube root of 2. So now we have the same bases inside the radicand. Equals, the next thing that we have to do is to use the fourth law of radicals. The fourth root of 2 squared may be written as the square root of the square root of 2 squared, because we have the square root here and another square root here, and 2 times 2 is equal to 4 times the cube root of 2. Simplifying further, we already know that the square root of 2 is equal to 2, so only one square root would remain in this term. Square root of 2 times the cube root of 2. The next thing that we have to do is to change these radical terms into exponential terms. So square root of 1/2 has an exponent in the radicand 1 here, and its root and its index is equal to 2. Same as in the cube root of 2, it also has an exponent in the radicand which is equal to 1. So to transform this into an exponential expression, this would be equal to 2 raised to 1/2 times 2 raised to 1/3. And then to change it to the same order, we have to get the LCD of the exponents 1/2 and 1/3. So the LCD will be equal to 6, and then we have to get the numerators of the exponent. And to do that, we have to multiply the LCD by the denominator and then multiply it by the numerator, same as this one. So 6 times 2 is equal to 3 times 1, that is 3. 6 times 3 is equal to 2 times 1, that is 2. And then now, we may now change it back to a radical. So 2 raised to 3 over 6 would be equal to the 6th root of 2 raised to 3. and 2 raised to 2 over 6 would be equal to the 6th root of 2 squared. And now that we already changed the given radicals into same orders, we will now proceed to multiplying the radicands. So that would be the 6th root of 2 cubed times 2 squared. And 2 cubed times 2 squared is equal to 2 raised to 5. And 2 raised to 5 is equal to 2 times 2 times 2 times 2 times 2, and that is 32. And this would be our final answer.